Hi everyone, welcome to part 2 of the lectures for week 3 for Exercise Science 198. And what I'm going to do here with this part of the lecture now is just literally go through your lecture slides one by one. So I've got them up on my screen on the left hand side. I'm literally just going to go through each of the slides bit by bit and talk to them as we go. So if you start on the actual title page of the lecture, which is L3, Biomolecules, Macronutrients, and that's what we're really discussing in the first part today. We're actually talking about carbohydrates. So the first thing I want you to do is I want you just to stop the video. I want you to have a look at the learning objectives and specifically look at the learning objectives related to carbohydrate metabolism. So that's the first one. Read through those learning objectives and then let's turn the video back on and then you can really sort of try to link up with what we're talking about in relation to carbohydrates. So we start with looking at what we've done previously, which is the biomolecules and looking at the production of them through photosynthesis and cellular respiration. And you guys have been through that before. We've seen how different forms of energy are made and how they're stored within the body. And then one of those molecules that we look at within the human body that stores energy is called the mitochondria. So now we're on the slide, it says metabolism and the mitochondria. Now here specifically, we know that the energy or ATP, pardon me, that molecule, most of the ATP is made within the mitochondria itself, so like 95%, and some other is made through anaerobic metabolism in what's called the cytosol. But the majority of it's made is made in the mitochondria, and we know that that's what we call the energy powerhouse of the cell. So when we talk about breaking down fats or carbohydrates to make ATP, that process is done predominantly in the mitochondria, which is predominantly found in slow twitch muscle fibers. Okay, and the more mitochondria you have and the bigger they are, the greater capacity you've got to actually produce energy and make ATP and do work. So if we go to our next slide, which is entitled carbohydrates, you can see that slide there now. It's just got 4 different versions of carbohydrates you might have seen before. So you've got sugar cane there in the top right hand corner, and then you've got the actual sugar cubes themselves on the left hand side. You've got some pasta and you've got some wheat. Now the first thing to understand about carbohydrates is they're not all the same. They're not all created equal. Some of them are more what they call simple and some of them are called what we call more complex. But in reality, chemically, what that means is some of them are called monosaccharides, some are called disaccharides, and some are called polysaccharides. So really, the more complex the carbohydrate, the more chains it has on it, and therefore the longer it takes to break down, but the more energy it has. So if you've got these 4 things we look at now, it just gives you an idea of the different types of molecules that entail carbohydrates. So if we go to the next slide, it's just describe what I've just said in relation to the type of carbohydrates. But we know that the monosaccharides, what we call the real simple sugars, are mainly glucose and fructose. And they're actually chemically, they look very similar, but the body metabolizes glucose and fructose very differently. And that's something we'll discuss again further down the chain. But it's good to understand even something that's very similar in its structure in glucose and fructose, which are both monosaccharides, the body actually treats them very differently. So the first thing to recognize here is the body actually treats all these cells in a very different way. Now, disaccharides are more complex. So they're normally what we have 2 monosaccharides come together and they form what's called a disaccharide. And examples of this is what they call sucrose or what we call sugar, right? So sugar is actually a disaccharide, believe it or not. Then you've got other ones called oligosaccharides, but we mainly refer to polysaccharides, which are more complex carbohydrates. And they're things like starch, or our form of energy we store in the body is what we call glycogen, which again we'll talk about later in the lecture as well. Now the important thing to understand here as well, the question here at the bottom of this slide is how much energy is released from the oxidation of 1 gram of carbohydrate. Remember what we say there, we talk about the oxidation, we talk about when we burn carbohydrate. So when we oxidize it, in the presence of oxygen, when we burn it, how much energy is released. Again, I want you to stop the video. I want you to go back to your lecture slides from last week. I want you to find the table that says the energy that's released from 1 gram of 1 gram of carbohydrate, fat, and protein. And then I want you then to come back to this slide here because I don't want to just keep telling you. I want you to go back and try to recall it and then try to remember it. So remember, carbohydrate, less energy is released than the same molecule of fat per gram. So therefore it's more simple. It's immediate energy, but there's not as much of it in relation to fat. So just stop the video, go back there and then come and join us back and once you've gone through and found that information. Alright, so if we go through looking at the next slide, it actually looks at the structure of glucose molecules. So we're now starting on that monosaccharide again, but we're looking at its chemical structure. Now, you're not going to need to try to regurgitate the chemical structure of glucose, so please don't even try to remember, oh, it's got 6 carbons or 12 and it's got 6 oxygens. The point here is just look at the molecule itself, and it's basically what we say, it's like a hexagon shape, and it's got a carbon at each of those points. Alright, it's got 6 carbon atoms, it's got 12 hydrogens, and it's got 6 oxygen. But just have a look at the shape of it and look at the chemical structure of it. Okay, and that slide's just a really good indication there to show the black molecules are the carbon, the red ones are the oxygen, and the blue ones are the hydrogen. And you find that most of the molecules that we look at in carbon chemistry have these three elements involved with them, and it's just a combination of how they're structured together. But really, that's the basic structure of carbon chemistry, which is obviously carbon, oxygen, and hydrogen. The main thing you need to know from this slide is look at it, it's a hexagon ring if you like, and it's what they call a monosaccharide. Now, interesting thing there, we look at fructose. Now, fructose is very similar to glucose, except you look at the OH group is now pointing down. In the previous slide, you could see the OH group and some of them weren't pointing down all the time. In this particular one, you see that the OH group is actually pointing down. So that's where it's slightly different. But again, too, structurally wise, it looks very similar to the glucose molecule. It's still a monosaccharide, but as we'll talk about later, the body actually doesn't metabolize fructose in the same way that it does glucose. So that's why you hear a lot of things in the media about fructose and high fructose corn syrup and all these different things. And the reason why they say that is because things like corn syrup is actually not really a natural product, believe it or not, but it's not naturally made like that. How they actually make corn syrup is rather than using glucose, which they would have used before in sweet drinks or cakes or things like that, they found it much cheaper to actually change the molecule of glucose and convert it into something which is much easier and cheaper to manufacture in the form of corn syrup. And the body doesn't treat it as well, it doesn't metabolize it really well, so therefore can circulate around the body a bit more and cause a little bit of inflammation. Therefore, fructose gets a bit of a bad name because of the way the body metabolizes. But it's just important to know the differences between the two. Okay, the other monosaccharides we look at a lot within the human body, in this slide here, are called ribose and deoxyribose, and they're basically related to the structure of DNA. So again, nothing that we really focus a lot about within this particular subject, but it's just good to know there are other forms of monosaccharides. Now we go to what they call a disaccharide. Now the important aspect here to look at is disaccharides can be made and they can be broken down. Now the top of the slide here, we're going to look specifically at the molecule called sucrose. Now if you look at sucrose, sucrose is made when you combine the glucose molecule and the fructose molecule together. Now when they combine together, that's a process known as dehydration synthesis. So whenever you hear the word synthesis, it means building. So you're making something, building it together. So if ever you're trying to work out, is it building, is it breaking down? If you see the word synthesis, that's making something. And here, glucose and fructose are coming together to make a molecule called sucrose, which is a disaccharide. Now the thing here to look at here is this happens in the form of an enzyme, which again we'll speak about later on, the role of enzymes and how they work in the human body. But the dehydration synthesis is the building of a molecule. Now on the flip side, we might want to break down sucrose in the body if we want to use it for immediate energy. And the process by which sucrose is broken down to glucose and fructose is known as hydrolysis. So hydrolysis is in the presence of water. So with water, we are actually able to break down that sucrose molecule and produce glucose and fructose, which we can now metabolize and use to actually make ATP. So that's really looking at a disaccharide. Now, in relation to another disaccharide on the other slide, next slide, it's called maltose. And maltose is when we combine two glucose molecules together, and that's commonly found in beer. So you might have heard of that before, but again too, it's found in wheat as well, and it can be formed, I guess, a number of molecules to form what's called a polysaccharide as well. So that's another example of a disaccharide. Now, the next slide we now look at what's called polysaccharides. So in relation to polysaccharides, they're really these really long chains. So rather than just two molecules together like a disaccharide, a polysaccharide are molecules or chains and building block of things or linkages of different carbohydrates to come together as one big chain. So in this situation here, if you look at that bottom left-hand corner of this slide, there's a molecule called amylase and amylopectin. And both of those are what they call polysaccharides. And they're almost forms of what we call starch. So you see starch is more favoured a lot of times when we eat foods, or more complex carbohydrates, because they help with certain things within the body, but also too because they release their energy a bit slower because they're a more complex molecule. So it takes a lot longer to break them down, rather than a simple sugar can get broken down and used a lot quicker. So the whole purpose of this little bit is to understand the difference between a monosaccharide, a disaccharide, and a polysaccharide. And it's really good if you can try to remember some of the foods that are associated with those two things. So you know glucose, well, we know what that is. We know sugar, or sucrose, is a disaccharide, or so is maltose or beer. And you've got a polysaccharide in the form of starch. So things like potatoes and so forth are starches as well. So that's what we call a polysaccharide. Now, the next thing we look at here is how all this carbohydrate is stored in the body. So the body doesn't store it as glucose or fructose necessarily. It actually stores it in a molecule called glycogen. So glycogen is where the glucose or the carbohydrate is brought into the muscle cell, and it actually goes through a series of reactions which we'll talk about later, and it's stored as this molecule called glycogen. And if you see in this particular slide here, these little dots, that's a massive molecule of glycogen. So little almost glucose molecules all come together and they form this, this molecule called glycogen. So that's what it looks like in the body. It's our major storage aspect. So you've got to remember too that that's what we call glycogen. So when we want to make ATP, we don't just get glucose, we actually have glycogen already stored in our body if we've been eating food throughout the day or the evening before. And if our body wants carbohydrate or wants glucose because we want to make ATP really quickly, it actually goes to the muscle cell and finds this glycogen that's already stored, and it breaks it down to make some ATP, which again we'll talk about next week in weeks 5 and 6 as well. But that's just good for you to understand the process of the molecule of glycogen. Now, the next slide just shows what actually looks like in the body. So in the actual muscle cell, if you look through a microscope, it's really cool. You can see these little black dots. You'll see in these particular slides, little black dots on the slides, and they're these massive glycogen granules. So we can store a lot of glycogen in the body, but it's really important to understand, even if we ate like for 3 days straight, we just try to eat as much carbohydrate as we can, we'd be able to store enough glycogen in our muscles and our liver for only about 2 hours of high intensity exercise. So although we can store a lot, unlike fat, which we can have days and days and days of, carbohydrate, as much as we want to store it, we've only got enough for about 2 hours of high intensity exercise. So it's a really good immediate source of energy, but it doesn't last a really long time. All right, but it can be broken down really quickly and we can use it straight away. Right, so that's the term glycogen. Now, the last thing we look at now is a thing called cellulose, and cellulose is a type of carbohydrate, if you like, that's mainly used for the building of cell wall. So again, too, we don't really talk a lot about cellulose in this particular unit, but just good to know that the enzyme related to breaking down or making cellulose is an enzyme called cellulase. But again, we'll talk more about the enzymes and so forth later. So for you guys, mainly the point of that first bit is just to understand the carbohydrate metabolism. Any questions you've got, just email them through to me. And the next slide will be, the next lecture we'll look at will be on the biological function of fats or lipids. All right, thanks guys.